Hello everyone and welcome to Robot Operating System version 2 or ROS2 tutorials. In this ROS2 tutorial we explain how to write publisher and subscriber nodes in C++ from scratch in ROS2 Jazzy Jalisco. The material and techniques that you will learn in this tutorial are the core of almost any ROS2 program. Namely, the complete idea of ROS2 is to connect different publisher and subscriber nodes and programs into a functional ROS2 communication network. In practice, a publisher node can be a program that is associated with a sensor, such as for example an encoder sensor, IMU, or a lidar, and that will publish a sensor information and data over an appropriate topic. On the other hand, a subscriber node can be a program that is subscribed to the topic and that receives the sensor information and performs computations. For example, a subscriber node can be a node implementing robot tracking, odometry, navigation, and obstacle avoidance. Over here you can see a simple demonstration of ROS2 nodes and program that you will learn how to write in this tutorial. In this terminal I'm running a publisher node. This publisher node publishes a message with a certain number. For example, the message is message number 511, message number 512, 13, 14, etc. These messages are sent through an appropriate topic to another node that is executed in this terminal. This node receives the message from the corresponding topic and prints the message in this terminal window. Now, although this example might look simple, this is a proof of concept for more complex examples. For example, this publisher node can be a sensor publishing, for example, position or angular rotation of a robotic joint. On the other hand, on the other side, we have a subscriber node that receives these messages, performs computations, and for example, it can do something very interesting such as obstacle avoidance or some advanced control. But before we start with explanations, we need to mention the following. Let's start with the copyright notice. This document, developed codes, and the lesson video should not be copied, redistributed, or publicly posted on public or private websites or social media platforms. The developed codes, this manual and video are the property of the author, and I am the author. My name is Aleksandar Haber. Without author's permission, this video and written tutorial as well as developed codes should not be used as an official or unofficial study or lecture material in university and non-university courses, as well as in online learning commercial platforms such as Udemy, Coursera, Udacity, and similar learning platforms. Without my permission, the code should not be included in academic works, student reports, and student papers or theses. Also, the developed codes should not be used in the commercial settings without paying an appropriate fee and without the permission of the author. Okay, so let's start with explanations. The first step is to verify that you have the proper Linux and ROS2 distributions. This is a very important step, and if you skip it, you might not have the correct Linux and ROS2 distribution and you will not be able to implement this tutorial. So click over here on Show Apps, then search for Terminal. And here is a terminal. Now I will resize this terminal such that at the same time you can see the manual and what I'm typing. Okay, so let's start. This tutorial is developed under the assumption that you have Linux Ubuntu 24.04, that's called Noble, and ROS2 Jazzy Jalisco. If you don't have this precise Linux distribution and this precise ROS2 version, this tutorial will not work for you. However, I created a separate video tutorial explaining how to implement subscriber and publisher nodes in C++ for Ubuntu 22.04 and ROS2 Humble. And you have that tutorial in one of the playlists on my YouTube channel. To check the Linux distribution, we need to type this. And over here, if you see 24.04, then everything is fine. On the other hand, you can also check the Linux distribution by executing this command. It's always good to know several ways for doing the same thing in Linux. Okay, and you can see Ubuntu 24.04. Next, let's make sure that you have the proper version of ROS. To do that, we need to go to this folder. This folder contains the binaries of all the ROS distributions on your system. So now if you type LSLA, you should see Jazzy over here. This means that you most likely have Jazzy installed on your system. However, to be 100% sure, we need to do an additional check. Let's try to source the setup.bash file by executing this command. Okay, looks good. And finally, let's see, will our system be able to recognize our ROS2 distribution? To do that, we need to print environment variable called ROS_distro. And let's see. And if as an output you get Jazzy, this means that you have installed Jazzy Jalisco on your system and you can continue watching this tutorial. Otherwise, I created a separate video tutorial explaining how to install Jazzy Jalisco on Linux Ubuntu. The next step is to create the workspace folder and the ROS2 package. To do that, let's first run this command. Oops, I made an error. However, let's run this command by opening a new terminal. So, in new terminal, let's run this. And enter your password. Now be patient over here. It might take some time for this command to execute. However, in my case, I'm running this command quite often, so you can see that it's executed in several seconds. Next, let's install gedit. Gedit is a very powerful and simple to use editor for writing programs. Okay, now we have gedit. The next step is to make sure that Colcon with extensions is installed. To do that, we need to execute this. Okay. Colcon usually comes with ROS2 distribution, however, it's still a good practice to make sure that Colcon is actually installed. Okay, to be able to create subscriber and publisher nodes, we need to create a workspace folder and the ROS2 package. So let's practice sourcing the environment and doing things from scratch. So again, open a new terminal, and whenever you want to do something in ROS2, it's very important to source, or better to say to execute, this setup.bash file. This setup.bash file will set up ROS2 on our system. Okay, now we are ready to create our workspace folder. First of all, let's go to our home folder by typing this. And in our home folder, we need to create our workspace folder. And inside of that workspace folder, we need to create a source folder. To create a folder in Linux, we need to use this command. This -p means that we are actually creating not a single folder, but we are creating several folders. We are creating this workspace base folder, and inside of that folder, we are creating the source subfolder. Okay, so let's do that. Good. Now, over here, ws sub pub is the name of my workspace. You can also change this name as you wish. However, do it in the second iteration once you learn and once you properly understand what I'm doing. Now, let's navigate to our source folder. Why do we do that? Well, it's a standard convention to place all ROS2 packages in this source folder, and consequently I will navigate there and then I will create a package. To create a package, I need to execute this command. So this command, which starts with ROS2 package create, and then I'm specifying type of the build, it's m and cmake. Cmake is basically type of the build, and over here I'm specifying the name of my package. The package will be subpub. Again, you can change this name later on once you know very well what's happening behind the scenes. And I will press enter. Now, what you will see over here, you will see our main package folder, subpub, and in that folder we are going to place our source files. So let's continue. the next step is to create the publisher subscriber files. So let's do that. To create the source files, first of all, we need to navigate to this folder, and we will use gedit to create our publisher.c++ file. Okay, over here I'm using gedit, however you can use some other editors such as Spider or even Anaconda Spider or even VS Code. It's your own choice. However, I like gedit since it is very simple. Okay, over here to save the time, I will simply copy and paste the content of the publisher file, and I will go over this file line by line. Okay, so what's happening over here? Let's start. First of all, we need to include the string library. Then we need to include the time library. Then we need to use library used to manage dynamic memory. And over here, since we will be sending std messages of the type string, we need to include this header file. This is a standard ROS2 header file. And then we need to include the C++ ROS2 client library. Okay, so here it is. Now we need to use this namespace, and what you can see over here from here to here is what every publisher node should contain. Okay, and you can see this file even as a template, and you can build upon this file. You can add some other functionalities depending on your application. So what is the standard practice in ROS2 is to embed the publisher, subscriber, and other nodes in a C++ class. So the idea over here is to inherit from the ROS2 node class, and that's precisely what's happening over here. I'm defining a class, simple publisher, that's the name of the class, and it is inherited from RCL CPP, and that's the C++ API ROS2 library, and we have node. Okay, so we're inheriting this class from ROS2 node. Here is our constructor. I'm calling it simple publisher since the name of the constructor have to match the name of the file. And over here we are calling the constructor of the parent class with this string publisher node. This is simply the name of this particular node. Then, what this publisher node will do, it will transmit messages with increased string value. That is, it will say, I'm sending message 1, sending message 2, sending message 3, and over here I need to define counter values. This counter value will count the number of messages, and I initialize it with 0. Now, I need to define my publisher object. To define the publisher object, I need to call this create publisher, then I'm specifying the type of the messages that will be transmitted through my publisher. I plan to transmit strings, and I need to specify the name of the communication, actually better to say the name of the topic. In my case, the name of the topic is communication topic, and that's the name that I gave to this particular topic. Of course, you can change this name of the topic, and the final value is the size of the buffer. The size of the buffer is the value that you will basically use to store the messages. That is, for example, if something happens and one of the nodes is down, then you will buffer last 20 messages. Okay, so this is how we create actually the publisher object. However, this publisher object is a private variable of our class, and you can see it over here. Here you can see the definition. Okay, here we create the object, or we basically declare it. Now we have publisher object. We have the counter. Now we have to connect all the pieces together, and we need to define the so-called callback function. So what is the main purpose of the callback function? The callback function is actually executed with a certain period. That is, you can imagine that behind the scene, ROS2 has a clock that ticks, tuck, 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 tuck. And we can specify actually the period, and that period will be used to transmit messages. That is, if the period is 1 second, every 1 second we will do something. That is, we will call every 1 second the callback function. Okay, so the callback function will be called periodically, and we can specify that period. We will do it later. Now, what you can see over here is super new C++ notation. What we are defining here is the so-called lambda function. This lambda function doesn't have input arguments, as you can see over here, and it returns simple void. And it performs a by reference capture of the current object this. Okay, so that's the meaning of the syntax. Void is return value, this is the lambda function, and the lambda function performs a by reference capture of the current object this. This is a new feature of C++, actually not relatively new. It exists maybe for 15 years already. However, it really compresses the syntax. Okay. However, you need to know what's happening behind the scene, so my suggestion is to follow this link to read more and to learn more about lambda function C++. However, you will be able to understand by just reading this code what's happening inside. So what this lambda function is doing, inside of this function we increase the counter value, then over here we create an empty message of the type string, then we fill in the message content by just filling this variable message.data. So what is our message? Message number plus, then we convert the counter value to actual string and we add two strings together. So that's our message. The message will be simply message number 1, then message number 2, etc. Then over here we print a message to the terminal of the publisher node. To do that we use RCL CPP info, we retrieve the logger, and we specify the type of the message that's being printed on our terminal. So we are saying published message, and we simply print the message that's stored over here. However, we still didn't actually transmit the message, or better to say published message, through the appropriate topic. The topic name is communication topic. So to do that, we simply call publisher object, publish, and we specify message, and that's it. So this callback function will increase the counter value, it will create the message, then it will combine the two strings, create the final message, and publish this message through the topic whose name is communication topic. And note that this name, that is the communication topic, should match the name of the topic on the other side. That is the name of the topic that's defined in the subscriber node. We will do that later on in this tutorial. Over here, we need to connect all the pieces together, and we need to create a timer object. Here we actually declare timer object. However, over here we actually define the timer object. The timer object is actually a private member variable of our class, and here is how it's being defined. And over here we simply create the timer object. We call this function createVolTimer. We specify the period. This is very important. So with the period of 1000 milliseconds or with the period of 1 second, we will call the function called callback function. And simple as that. Now, over here we can see the private variables there, the timer object, here how it's being created. Then we have the publisher object. Here we use the publisher object as well as here to publish the messages, and we have the counter value that's being incremented over here and initialized over here to 0. And that's it. Now here's our int main function. We initialize ROS2 by calling init. Then over here we spin the node. This will actually call back, this will initiate the call of the callback function, and over here we have a simple shutdown that will shut down everything once the user presses Ctrl+C. This spin function is a classical ROS1 function that's being inherited in subsequent versions of ROS2. So we initialize, we spin the node, and we shut down, and we simply return 0. The next step is to create the source file of our subscriber. To do that, we need to call gedit with the name of the file. I will call the file subscriber.cpp. Okay, and over here, to save the time, I will simply copy and paste the content of the subscriber, and let's explain the subscriber line by line. The structure is very similar, with few differences. First of all, we include memory, then we need to include string.hpp, then we need to include the C++ ROS client library. Then over here again, we encapsulate our subscriber node inside of a class. That is, we define a class that implements our subscriber node. Here's the name of the class. This class again inherits from our node. Here's the constructor. We are here calling the constructor of the parent class, or better to say of the base class, and we specify the name. The name is the subscriber node. You can change this name later on if you want. And here is the main difference. Here immediately in this constructor we define our callback function. So what's the purpose of callback function over here? Once the message is being detected on the topic, this callback function will be called. And that's why here, as the input of this lambda function, you actually have the type of the message that we expect to receive. And you can see the type of the message over here. Okay. And again, this is the standard way of defining the lambda function. It returns void. Okay, so what's happening inside of this callback function? Over here, we just print the message in the terminal window. We use this function rclcpp, we get our logger, and then inside of the terminal, we print I heard, and we precisely print out the message that's being received. That is, you can see that we call message, then this method data, C to string. Okay, good. And that's it. Simple, and that's that. Now, over here, we need to create, or better to say, to initialize the subscriber object. Note over here that we only have a single private member of our class, and that's the subscriber object. And over here, I actually create its value, or I set its value. So what do? I call create subscription. I specify the type of the message that we expect to receive, their standard message string. I note here that there is exactly match between this type and the type over here. This is very important. Then we need to specify the communication topic. That is the topic name. In our case, it is communication topic. Then I specify the buffer size. So if something goes wrong, we will store like last 20 messages. And finally, I need to specify the callback function name. In my case, the callback function name is given over here. And that's it. Simple as that. Then we have the private variable, which is our subscriber object, and nothing more and nothing less. Simple as that. And here's our int main function. We initialize ROS2 by calling init, then we spin the node, and this spin function will actually set everything and perform the callbacks of our callback function. And then finally, if for example users presses Ctrl C, we'll shut down everything and we will return 0. Simple as that. Okay, so that was subscriber.cpp. That is the source file of our subscriber. The next step is to add the dependencies and to add it two very important files. We need to add the file called package.xml and cmakelist.txt. These files are located inside of this folder. That is, they're located inside of the source folder and inside of the subpub folder, which is a base folder for our package. So let's navigate to that folder by running this command. And inside of this folder, let's edit package. However, before we edit the package, let's make sure that we have the package.xml. Here it is. So let's edit the package. Okay. Here we need to perform several edits. Now, let me explain first of all the purpose of these edits. Now, in our subscriber and publisher nodes and their source files, we are using two standard ROS2 packages. They are the RCLCPP, this is the ROS2 C++ API, and we are using standard messages. And consequently, we need to tell to ROS2 and to our package manager that we are actually using external dependencies. That is standard ROS2 dependencies. So to do that, we need to add these two lines. So let's do that. And we need to add these two lines, for example, over here, below actually the test dependencies. So let me just do Control Z. Okay, cool. So here they are. Now let's save this and let's continue. Now you can safely close this file. So let's save it and close. Now we edited package.xml. The next file that we need to edit, oops, I made an error here. Let me just make sure that I'm not destroying my manual. If you again type ls-la, you will see the cmake lists file. So we need to edit that file. And we need to make 3 edits of this file. Okay, good. This is the cmake file that actually configures the complete build process. And first of all, you can see over here that there is something called find package. And we want to find the package element cmake. However, we need to add 2 additional find package commands. So these commands are actually find package rclcpp and find package standard message. So let's add them over here. Okay, so this will tell to cmake to search for rclcpp and standard messages. Okay, so let's continue. Next, we need to define basically our executable file names. Okay, now we have the source files, they are publisher and subscriber CPP, however we need executables. So let's learn how to do that. To do that, we need to simply paste, let me just do this. We need to paste these 4 lines, and I will explain them thoroughly. So what's happening over here? We are adding the executable. The executable name will be publisher node, and this is the name that we will use to add our to actually run our publisher. Again, the publisher name will be publisher node, and that's the name of the executable, and we will use this name to run our publisher. The source file is also defined and specified over here. This is very important. And then we need and target dependencies. We are saying here that publisher node depends on the RCL-CPP and standard messages ROS2 packages. Okay, this is how we define the executable for the publisher node. Similarly, we need to define an executable for the subscriber node. The name of the executable file will be subscriber node, and this is the name that we will use to run the subscriber node. And here's the source file. It's the file that we just defined. And over here, we need to specify the dependencies. We are saying here that our subscriber node executable depends on RCL-CPP and standard messages. That's it. And next, we need to install targets. This is very important. Okay, we just add the executables over here. However, we need to install targets. That is, once everything is compiled and built, these executable publisher and subscriber node will actually be stored over here. This is the environmental variable. It's a standard, and then it will be in lib folder, and here's the project name. Simple as that. That's it. And let's save this. So these were our final edits. Perfect. Let's close this and let's continue. The next step is to perform the final build. To do that, we first need to navigate to our workspace folder. That is, the build should be called from this folder. Okay, however, let's verify that all these packages and all dependencies are properly installed. So to do that, let's make sure that we have actually ROSDEP installed. You probably have, since it should come with ROS. So let's run this again. Let's update just to have make sure that everything is in place, and let's finally run this. Okay, So this will check all the dependencies, and you can see over here that all required ROS dApps dependencies are installed successfully. This is very important check. Now, simply ignore this error sudo ROS dApp init since it doesn't change anything. This just tells you that everything already exists. Okay, good. The next step is actually to build everything. The easiest way, but not the fastest way, to build everything is to simply call callconbuild. So call callconbuild from this workspace folder. And it's very important that you actually call this function, or better to say this command, from this workspace folder. That is not from the package folder, but from the workspace folder. So let's run this, and I'll be patient over here. So what's happening, we're basically building our package. However, as you can see already over here, it takes even a significant amount of time to build everything, even for a single package. Now, an alternative would be to select the precise package that you want to build. In our case, we only have a single package, so you can run callconbuild. However, if you have, for example, 1,000 packages, then callconbuild will most likely build everything. So instead of building everything, you can specify what you want to build, and you can do that by running callconbuild packages select, and you simply select the package. The package is subpub, and that's it. And finally, we are ready to perform the final test. To perform the final test, let's start from scratch, open a new terminal, and as I mentioned at the beginning of this tutorial, you first need to source this file, setup.bash. However, notice now the difference. What I'm sourcing right now, I'm not sourcing the standard ROS2 setup.bash. I'm actually sourcing this setup.bash from my created package. You can see here's my workspace, and all the files are placed in install folder, and then I have setup.bash. That is, by running this, I'm sourcing my package. And this is very important. So there is a difference. You can source the complete ROS setup.bash, or you can source setup.bash from your package. Here I'm sourcing the setup.bash from my package. And to run the publisher node, I simply need to run this. So what I'm running over here, I'm specifying ROS2 run, the name of the package and the name of the node, and that's it. And you can see over here, published message, message number 1, 2, 3, 4, 5, etc. Good. So our publisher works perfectly. So let's open a new terminal and let's try to run the subscriber. Again, to run the subscriber, we need to source the setup.bash file of our created package. That's the first step. And then the next step is to run ROS2, run subpub and our subscriber node. Subpub, again, is the name of the package, and subscriber node is the name of the node. And that's it. So let's see what's happening. I heard message 39, 40, and you see that they are synchronized. So currently here there is, for example, 47 that's being sent, and 47 is being received over here instantaneously. Okay, that's all for today.